Welcome to EPG Pathashala. My name is Vidya Vasanta. I am on the teaching faculty of the Department of Linguistics at Osmania University. My lecture pertains to course number 10, Psychoneurolinguistics, and today's lecture deals with module 21 on aphasias. The objective of today's lecture is to point out to the inadequacies of classical model of brain-language relationships to characterize aphasias. I will not be able to talk about the alternative ways of characterizing aphasias, but it is also important to realize that there are a lot of limitations to the classical model which existed for more than 100 years. So, I hope to be able to point out those limitations and share some new insights from neurolinguistics which is saying that it's time that we gave up on classical model and talked about models which say that language production and processing draws from both left hemisphere and right hemisphere, and our notion of Broca's area and its contribution to speech production is extremely limited. Broca's area is involved in more functions than just speech production. Let's start one more quick look at the classical model. On the screen you are shown that picture with Broca's area being involved in production, Wernicke's area being in charge of comprehension. Both are connected through arcuate fasciculus, and Broca's area is sending information to motor cortex in the frontal lobe. Motor cortex sends signals to the speech muscles to speak. So, this is a typical left hemisphere dominant processing of language. This is a classical model. What are some of the assumptions of the classical model which we have not dealt with earlier? One is called fractionation. What classical model is saying is, it is possible for intact and impaired language abilities to coexist after brain injury. So, what is happening when you have a brain damage? You have Broca's area intact, Wernicke's area is damaged, or Wernicke's area is intact, Broca's area is damaged. So, impaired and intact areas can coexist. This is what is called fractionation assumption. Then the second one is called transparency assumption. Pathological condition can tell us about normal system. That's an assumption. So, by studying aphasia, by studying Broca's aphasia, we can learn all about production. By studying Wernicke's area, we can learn all about comprehension. That's the assumption. That's a transparency assumption. Third assumption is subtractivity. That is, a given patient's performance reflects normal cognition minus damaged module. As I told you, classical model endorses modularity. So, when you see an aphasic patient's performance, the classical model is saying that this performance reflects normal cognition minus the modules, because one module is damaged, right? So, this is supported by the notion of dissociation versus double dissociation in neuropsychology. You need to understand what is dissociation and double dissociation in neurolinguistics. How do they test for this so-called dissociation? They use picture naming, repetition, discrimination of minimal pairs, word, non-word decisions. So, they look at performance of patients on tasks like this, and then they look at which is more damaged to particular subsystem read module of language processing, and they try to say, lexical items are stored in temporal lobe, he is not able to name properly, therefore temporal lobe is damaged, right? That's how the reasoning goes. And this kind of reasoning, supported by classical model and modularity assumption, led to serial modular models of information processing in neuropsychology. So, here they paid greater attention to the boxes. If suppose there is a model of speech production, there are boxes and there are arrows, but attention was paid to the boxes but not the arrows, because arrows are transmitting information from one box to the next box. So, they ignored the arrows and they paid more attention to the boxes. So, as a result, they said, so dissociation is this: Broca's aphasia disrupts speech production but not speech comprehension. Wernicke's aphasia disrupts comprehension but not production. This is what is called dissociation. Right? Lesion A damages function A. Lesion B damages function B, and not the other way around. So they are dissociated. What is double dissociation? In Broca's aphasia, conceptual knowledge is not impaired, but syntactic knowledge is affected. In Wernicke's aphasia, just the opposite. Syntactic knowledge is not affected, but conceptual knowledge is affected. So there are two functions, there are two areas, and there is a double dissociation. Right? As opposed to this modular models of information processing, the classical model of brain-language relationship, connectionism, I have already explained in the last module. Connection is said we need to develop online tests. Okay, so previously they were using offline tests like Boston Diagnostic Aphasia Examination, where it is not possible to observe what exactly is happening in the patient when he is naming or when he is repeating or when he is writing or copying. What processes are happening online is not possible to observe. You have given a stimulus, the patient responded, and that's it. You don't know what exactly happened. Connectionists are saying we should actually watch what is happening using online tests. And it promoted a whole lot of parallel processing, distributed parallel processing models which deal with distributed representations. Representations are not fixed anymore. They are distributed all over. And they have, questioned all the three assumptions of the modularity and the classical model. Fractionation, transparency and subtractivity assumptions of the modular models are not tenable anymore, is what connectionists are saying. So in other words, in the past couple of decades, there has been a lot of discontent with the classical model of brain-language relationships. They are saying if language-related areas are embedded in different cortical networks, you have seen the networks for verbs are different from networks for nouns. So if several networks are involved, how can we talk about damaged module? How can you have say that damage is to this in a particular area identified, for instance, by the Broadbent area number 22 or number 17 or number 44? How can we say there is a module there which is affected when network is spreading across two hemispheres, right? That is one discontent. Neural reorganization. How do you explain after a brain damage, after 2 or 3 months, language is coming back? So what happened to the module? If the module was damaged, how is language coming back? How is reorganization taking place? They are asking that question. Classical model also failed to explain effects of age, handedness, education, language learning and using histories of aphasic patients. That recovery is different in multilinguals, bilinguals, depending upon the amount of language they are using in how many different domains. All that was ignored in the modular perspective using classical model. So, discontent continues with classical model, especially using a whole lot of recent research. They said generative linguists have talked about a sentence as having different constituents, making up a tree, syntactic tree diagrams. These tree diagrams were used to explain grammaticality and things like that, right? They were useful in defending certain theories of syntax, alright, but they served little or no function in capturing actual algorithmic operations that are happening across the network. Cortical networks are getting excited when we are processing language, but the tree diagrams cannot help us understand that particular algorithmic operation which is happening in milliseconds. How can you use a tree diagram to explain a millisecond level operation is what connectionists are asking. So, in other words, classical model is dead. So I'm calling it depth of the classical model. And I use this word because I like this quotation from Popple, Emery and Heacock, neuroscientists and Pilkanen. In 2012, they made this statement, the era of the classical model is over. The underlying conceptualization of the relation between brain and language is hopelessly underspecified, both from biological point of view as well as from linguistic and psychological perspective. So, classical model is dead. Okay, now what is the alternative they are proposing? They are saying, don't simply say Broca's area is number 44. It's not just 44. Look at 45, look at 47, look at 46. Look at the figure on the screen. You have seen the entire red area contains 44, 45, 46, 47, and it's much more that they are saying Broca's area is not in charge of just production. It does various things, right? They are saying Broca's area is playing a role in selecting different representations. By now, I hope you have understood that the representations like phoneme, syllable, word, they are not stored in one place. Broca's area selects appropriate representation when there is conflict among competing representations by drawing on top-down information in addition to processing that is coming from working memory and storage capacities. In other words, Broca's area is connected to a whole lot of general cognitive architecture of the brain, and so for instance, Broca's in the BA44 area shown to you in the figure on the screen, just now, is involved in phonological processing. BA45 is involved in syntactic processing. BA47 is involved in semantic processing. So, the point that you have to note is, as an area which was simply called Broca's area is involved in phonological, syntactic and semantic processing. The entire language is being processed in one area. So, where is the question of different modules? All three areas are activated in PET and in MRI and this kind of experiments when there is violation of pragmatic interpretation of a sentence. Alright? In other words, world knowledge is not left out. World knowledge should be part of our analysis of comprehension of a sentence. Broca's area is involved in non-linguistic information processing. Not linguistic alone, non-linguistic information. Evidence is available today to show that BA44 and 45 are involved in a number of non-linguistic tasks like motor activation, motor imagery, rhythm perception and things like that. Broca's area interacts with domain general areas such as visual cortex. Occipital lobe, visual cortex is located in occipital lobe. When you are listening to sentence processing, why should there be activation in visual area? If modularity is correct, there should not be any activation in the visual cortex, but there is. Alright. So, Popple 2012 cited magnetoencephalography. It is called MEG. It's a very costly equipment, powerful equipment. They did studies using MEG and they demonstrated that syntactic and lexical semantic cues in the input affect neural activity in the occipital lobe. So, syntax and semantic processing is giving rise to activity in the occipital cortex between 100 and 130 milliseconds, reflecting predictive nature of online processing. So, these people are talking about when you are processing a sentence, you are going ahead, you are predicting what is going to come ahead, alright. And for some reason the occipital cortex is also getting activated, which means there is a lot of interaction across lobes. So, all this make neuroscientists and neurolinguists to talk about, in place of classical model of brain language, they are talking about whole brain perspective on language-brain relationship. The temporal lobe deals principally with memorizing, that is storing, parietal lobe with analyzing, frontal lobe with synthesizing. Notice how we have shifted now from activities of language of production, comprehension, reading and writing. They are not speaking like that anymore about language. Language is not production plus comprehension plus reading plus writing. They are saying we analyze, we synthesize, we store, we memorize, we retrieve. These are functions of language. And in this, temporal lobe is involved, parietal lobe is involved, frontal lobe is involved, and very often within each lobe, the functions are distributed. Let's look at the picture closely. Within each lobe, there are individual dots, colored dots. Each one refers to the area which is involved in phonetic, phonological, or syntactic information or semantic information. So you can see. So, for instance, in the temporal lobe, the blue dot, the blue, yellow, and red dots are basically, they correspond to phonetic, phonological, or syntactic or semantic level processing in relation to memorizing, analyzing, or synthesizing language. I hope you have studied the picture. Now, let's move on to the next slide. Okay, you might want to know what is great about it, what is the implication of adopting this whole brain perspective on language-brain relationship. The whole brain model and the dual root model I have talked about in the previous module forces us to rethink the meaning of hemispheric specialization, which is a huge thing which dominated the field of neurolinguistics for a long time, that all right-handed people have left hemisphere dominance for language. It's like, taken for granted assumption, which is being questioned now. The discrete representations involved in speech perception, now they're saying they have to make contact with higher level lexical representations according to the whole brain perspective, because the lexical representations draw on memory, and therefore, speech perception also involves stored representations, lexical representations, and memory is also involved. Therefore, theories of audio-visual speech perception must at some level be linked to theories of lexical representation. So, you cannot talk about audio-visual speech perception as one module and lexical semantic module managing only stored words which are there in your mental lexicon. You can't talk about them as two modules. They have to make contact. Then even the evidence from magnetoencephalography is saying that when we process language, there are two modulation rates in speech sounds. Low gamma band is about 20 to 80 millisecond processing. It's slow, and there is a theta band with 150 to 300 milliseconds, which takes care of syllables. So, auditory cortex implements temporal integration using both these time constants, slow and fast time constants. Theta band phase tracking involves right hemisphere lateralization, whereas gamma band phase tracking occurs bilaterally, involving both left and right hemispheres. So, this is MEG evidence is available for participation of right and left hemispheres if you look at temporal processing, not just spatial. In fact, MEG evidence is available to show that there are some subcortical structures are also involved in language. They are saying cerebellum and basal ganglia also play some role in processing temporal information. Auditory processing is coupled with temporal processing, and that even motor system is involved in temporal processing. So, okay, so we said classical model is dead. We talked about whole brain model. Now, with these new perspectives of left hemisphere, right hemisphere, subcortical structures, all of them are involved in language processing. Now, how do we characterize aphasia is what, So, against these recent research, one major question facing us is, neurolinguistic researchers, is whether aphasia can be thought of as an impairment that is specific to linguistic domain, or whether aphasia is a more general cognitive disorder affecting use of symbols and signs, both verbal and non-verbal. So, because of the whole brain model, we are able to raise new questions like this. Let me summarize what I have been saying in this lecture. I have expanded on the ideas discussed in the earlier modules, that is, the representation versus processing is what we discussed earlier. Basically, the non-modular, that is, whole brain perspective, which is supported by connectionism, questions the classical model of language-brain relationship. Especially 2 points that classical model has upheld. One is that left hemisphere is the dominant language related hemisphere. That is, all language functions like left hemisphere takes major role, right hemisphere is only minor. That is one point pushed by classical model. And the second point is that Broca's area in the frontal lobe of in the left hemisphere is in charge of articulated speech. In this module, I have presented some recent neurolinguistic research which has questioned both these assumptions. That left hemisphere is dominant, is being challenged. There is enough research now to show that right hemisphere is very much involved in lexical processing, in speech perception. And in fact, the current argument is we need to replace the classical model with whole brain perspective. That entire brain takes part. Even if you say left hemisphere is important in syntactic processing or whatever, the right hemisphere also is involved in other functions like integrating information, and the whole brain perspective in fact shifts the focus from spatial area wise, like where is what representation is stored, where are the words stored. From that debate, the shift is to within each lobe there is phonological processing, syntactic processing, semantic processing happening in at least frontal, parietal and temporal lobes. I have shown you enough pictures to demonstrate this whole brain perspective. So, it is the idea of this module is to tell you that there is a need to draw on these new insights in understanding the various aphasic syndromes which we are going to discuss in the next 4 modules. Thank you.